Hi everyone, this is Purnima Magalingam and you're watching video lecture series in solar and wind energy. Today in this video, we are going to discuss about the fixed speed wind turbine in wind generator topologies. Before going to the video, we will be having small introduction about this topic. So we have known that fixed speed wind turbines were the dominant technology until the early 2000, representing over 70% of installation before 2000s. They paved the way of modern variable speed design. This is what a small introduction about this topic. Come, let's go into the video. Now, here I'm seeing the introduction. What is the core point? Here we can see what is the core of early wind power. So first one, it is in a constant RPM, that is rotor per minute RPM. So that is fixed speed turbine operates at a constant RPM. And next one is direct grid connection. It is connected direct to the grid, and we have an aerodynamic control. So they connected direct to the grid via gearbox and transformer. Here the power regulation relief on aerodynamic star and pitch controls. So these are the core early wind power. Now coming to the components. What are the key components we have? It is uh, the fixed speed wind turbine primarily use squirrel cage induction generator. The rotor speed is fixed by grid frequency, typically 1500 RPM to 1800 RPM. The slip is very small, so, that is remaining from 0.5 to 2%. And there are no complex power electronics. It is a main pathway, in the main pathway, that we don't have any power electronics components. This is what a key component and operation. Now coming to the grid operations. Now here we have seen the grid operations. When we are connecting these to the grid, we are facing so many challenges. We are connecting this squirrel cage induction generator, fixed speed generator to the grid. We are facing so many challenges. We can see what are the challenges. First challenge is the reactive power. So if we connect it directly to the grid, we will be having more number of reactive power. The inner consumes reactive power from the grid and capacitor bank. So we need, if the reactive power increases, what happens? Large shunt capacitor banks are needed for power factor corrections. And next one is low voltage flickers. So can use voltage flickers due to the power fluctuations. These are the main challenges. And last and foremost important challenges is the mechanical strength, that improves strength, the significant stress on driven components. These are the challenges which are facing when the fixed wind energy generator is connected with the grid. Okay. Now coming to the advantages. What are the advantages of using fixed speed technologies? Main first thing is simplicity. We have known that it is simple design and operation. So design and operation is simple because of that is fixed speed, and reliability, then high robustness and reliability, and low cost. So low internal capital cost, about 15 to 20% less per megawatts, and mature technologies. A mature technology with extends expensive. These are the advantages of a fixed speed technology. Now coming to the disadvantages. What are the disadvantages? Is suboptimal efficiency, that is inefficient varying wind conditions, and high mechanical load, and causes reduced component life. High mechanical load and reduces component life during gusts, and poor power quality. Is a limited grid stability operations and limited grid services. It is grid services is limited. These are the main disadvantages. Now coming to fixed speed. Key fixed speed topologies. What are the topologies? We have two main topologies. One is type 1, next one is type 2. Type 1 is nothing but squirrel cage induction generator, and type 2 is wound rotor induction generator. Here we can see the squirrel cage induction generator. Next one is wound rotor induction generators. Here we can see squirrel cage induction generator, most common type generator, grid generator is an example of versatile model. And wound rotor induction generator is in with an external resistance. We have an external resistance and limited speed variation, smooth startup, and it is early Nodex mode. This is early Nodex mode. This is what squirrel cage induction generator mode. Now coming to here, it is finally we are concluding this with an this topic, the foundation of a wind generator. Here, coming with the foundation of wind generator is first conclusion is the essential historical role in commercial wind power growth. So, historical role first, it is used for windmill and it is used for um, mills and etc. And it is increases. So commercial, first it is from commercial to growth of wind power. Okay. Now coming to the lesson learned is shape modern grid code requirement. What are the modern grid code requirement and still present in order to form about 10 to 15 percentage per 2500 feet, and simplicity and robustness remaining value design principles. Okay, these are the points we are concluding from the wind energy topologies, generator topologies. And thank you so much for watching this video. We'll meet you again with another topic. Thank you so much. Have a nice day.